Google has recently published a book about site reliability and security engineering. I would like to utilize this episode in order to provide you with a brief overview of this book, and also I would incorporate my own analysis and thoughts about reliability and security engineering, taking into account what the book says. So I will save you some time from reading it, at least part of it, but I would also incorporate my own views and thoughts on the subject matter. Take a few of your customers and ask them, what are the top 5 features on my product that I provide to you and that you most like? The answers that you are most likely to get is, I really like how polished the UI is, or I really like the daily report that I get by mail, it's just fantastic, or since I started using your product, I was able to save 1 hour a day of my productivity. And it really boosted my productivity and my habits, and I now exercise more, so your application, your website is really great. Or that share button that you added, I really use it and I invited friends. This increased the popularity of the website that I built with your site. This you have done here just a great job. This is in general how Google opened this book about reliability and security. The fact that customers are not super aware of it can make it unlikely for you to develop these features as requests from the customers in many cases. So your customers are very unlikely to answer the question of what are the top 5 features of my product that you really like with, I really like its security, I really like that we lost no sessions in the recent month, I really like its reliability, there was no downtime. Of course there was no downtime. This is what they expect. This is the basics. No real customer will even think of it, especially if your product works well. Moreover, assuming you did a really great job, they will never notice these features of your product that you might have invested a lot of time. They won't notice these features as if they don't exist. And this should have us learn a big lesson. There are some features that normal customers are unaware of, but could be more important to this customer that didn't mention it more than other features. This does not mean that the customer does not need it. He needs it. He is just not aware that he needs it. And this does not mean that we should not invest time in it, of course. We are all investing time in it. The question is, how much and how exactly? What should we do with the time we invest to be the most effective? We have assumed with it that, of course, that the customer is a real and user customer and not, let's say, the on-call. We didn't call the on-call developer our customer. It's still a common sense that is used in many organizations that when you think of your product, then your product teams set the feature list and the engineers are there set to work and implement the features which are asked by the end user. The way to resolve this is to extend actually the list of customers. You should not only interview the end user, you should also interview the on-call as a customer. He is the best to tell you what's important to him as a customer, and then you should sum up a feature and create a feature list that includes solutions to all customers. This cannot be easily done. It requires a whole set of cultural and standards out of an organization, but taking this route is crucial to the success of your business. The secret is this, therefore. You need to start with the list of customers that you have, and they are not only the end users. To have a healthy organization with a healthy product, the list of customers include not only the end customer using your product, but also the internal maintainers of your product. Those are the developers which support, and the marketing teams and all the supporting teams that support your product, and also, especially in the context of reliability and security, the on-call personnel. As the Google SRE book claims, the security and the reliability should be top priorities for your organization, or at least among the top priorities of your organization. And this opens a complexity of its own, because while security and reliability share many features, they also have distinct features and design considerations. The door or the login to your servers can be very much secured, but for an engineer then to get in and fix something, to get into the server and to fix something, then a door or a login which is overly secured could block the developer from fixing that problem. So there is a tension in between security and reliability. In buildings, we have an escape pathways. For example, in case of fire, you have a secondary escape pathway that you can go through. But if we look at it, then this also introduces another door into the building for attackers. Hence, we see again that security and reliability design considerations often collide. Another example from security perspective, that you want the least amount of people to be able to access the logs of your servers, for example. But again, if we look at the least amount of people accessing your servers logs, then from a reliability perspective, you want more and more people to be able to access it so that multiple people could troubleshoot the issue. So the more complex it is and more security is, the harder it is for internal personnel to analyze and troubleshoot the problems. And you want more people to be able to access, you want more developers to be able to access the logs, because this increases the chances that you can solve issues and get more knowledge about how this system works. So incorporating the end customer could be a solution to the effort that is required. A customer who is acknowledged, a customer who is well educated, maybe by us, by the company, we could actually make it then visible and highlight in our website the security and the reliability of the system that we built for the customer, even if the customer does not understand anything about security, and he would be much happier. Even if the customer did not ask for it, and he would be much happier that we invested time in it. If you use Zoom or other softwares during the COVID-19 crisis, and you are not a technical user, then you would be much happier to see in the front page. This gives us an indication of how important of it. You would like to see in the front page as a customer that the organization that created this software invested in the security and in the reliability of the video chats. Therefore, this provides us with a kind of a solution that incorporates the customer in our effort to explicitly tell the customer you did not lose any voice calls to the outside world at all. And also, the voice calls of yours are not recorded in our servers because we proactively took these measures. When you logged in to our website, we remind you that your mobile phone, for example, is a backup to your login credentials. Okay, we can send you an SMS. Only by this reminding, the user is beginning to get aware and informed and educated about the importance of the security and reliability of the system, and thus we incorporate the user in our effort to create a more reliable and secure. And this would help us as organization to invest more time in it, because it's not only us that benefit from it, it's also the customer, and he would start even requiring it. Now, imagine that you have an application, let's say a stock trading website, and you have an issue that you then go and involve your developers and on-calls to fix that issue. What do you prefer in that case? The book asks, do you prefer a simple code or a complex code base? Do you prefer a system with clear boundaries or a system with complex system with undefined boundaries? So, of course, the answer is simple and clear boundaries, but this does not say, of course, that simple is always better. But if there are a few choices, we should strive to keep in our mind how simplicity is important. At the time of a crisis, when you have this crisis or issue, you want the system to be clear and simple. You want to be able to run some tests quickly. You want to be able to navigate the code quickly. You want to understand quickly where the issue is. And quickly does not get along so well with complex, but it does get better along with simplicity. This is a choice that we can explicitly make. It does not mean that our system is simple. It just means that there is a choice that we should make when designing and when investing the time in the system, that sometimes we had better look at the options, and simplicity is one hell of a major point in our system design. Now, we all know that markets move fast and features should be delivered faster and faster as time passes. This is why we have Agile, this is why we have sprints. But this can yield architects and developers to invest much less in the reduction of what is called technical debt. We should remember all that technical debt is actual debt. We need to take it. People take debt of money. Right? It's not something that does not exist. People take it, but it's best to take it when it's a kind of an investment, okay? But when we take technical debt, it's a kind of, we say what we're doing now is more important than the future time of the engineers. So take it explicitly when appropriate, but also be reminded that the complexity accumulates. And one day this may blow up. An example of this is taking a whole team and choosing one team member each sprint to cut technical debt. This is only one option. There is only many other options to do this, but this assures us that we actually dedicate the time continuously, and this is one method. For example, a small change on 2018 caused YouTube to be down for 1 hour. Just imagine it. YouTube is down for one whole hour. What was the cause of that? The cause of that was the removal of 2 innocent-looking lines of code which dealt with logging. This only stresses out that technical debt accumulates, and when we remove these 2 lines of codes, we have reached a tipping point where we saw that the problem exempts itself. In this example, it was a downtime. This makes it much harder to allocate time because you don't see the actual effect of the technical debt until we reach a tipping point where we cannot add features, the whole system is a mess. In addition to reducing the complexity and increasing the simplicity and increasing the visibility by reducing the technical depth, there are other what is called defensive approaches, such as limiting what is called the blast radius. When designing and coding features, what can help in this defensive approach is that we ask ourselves, what happens in case of total failure? How can we avoid a total failure on the whole system? How can I ensure that if my code does not run, that it's not taking the whole system down with it? Or even better, how can I ensure that the blast radius is as small as possible while keeping the system still simply and easily to maintain? Some of this can be done by limiting the access of people to different projects. So one person cannot access other projects he's not supposed to. This is only one defensive method. This reduces the blast radius of what potentially the developer can do. And this is separating the domains into distinctive failure domains. There are many additional approaches to this. Usually, we tend to think of security attackers as attackers from the outside of the organization, but they could also be from the inside of the organization. It could be intentionally or unintentional. What we could do to mitigate that is called also the principle, one of the mitigations is called the principle of least privilege, where you give the least privilege to people unless they really need it. And I would also say it's best not to distinct between external and internal attackers. Just treat the whole problem as one holistic problem. Also, another defensive method to mitigate that is a multi-party authorization. This is another tool that enforces when you have sensitive operations to be performed, only when multiple parts authorize this operation. So it's just like multiple people needing to hit the red button for an atom bomb to blast. This both protects against inside malicious users and also against unintentional operational mistakes. So before deploying a system or a process, then you should take some measurements to make sure that the system behaves well before and also after the deployment. Because almost any reliability or security problem, it happens in many cases after you do a kind of a change. And even if you had prior a solid design, which you then translated into code by the developers, then this does not mean, of course, that the code is well suited for reliability and for security. So you need to take the appropriate tunings also when coding, of course. The main point here is that a design which is well secured, like looking well secured and well polished and well reliable, is not enough. It's not enough to have that the security and reliability on the architectural diagram. Another way for us to be more defensive on against the problems with reliability is to slow the rollouts. This would help in checking that the features are running well on a small set of users and less risky consumers while you propagate the feature on and on. So, while it's usually said that we deploy 100 times a day, it's not wise to deploy to everyone at once. If you have a slowdown deployment, this means that only part of the users receive it and then another part until you reach the whole mass of the users. So you do the staging of the tests. And with all our efforts to prevent errors, to prevent security holes, to make our reliability extreme, it would happen. Errors would happen. And we cannot be actually totally resilient or secure. So we should prepare to what happens when this error actually happens. So we want to have the logs, we want to have the monitoring, we want to be prepared for errors. Specifically for logs, we want more logs. In general, we want more logs. However, it's not possible always. The more logs we have, then we can search them. We can search more. But, however, searching them would be slower. At a certain scale, the logs become too expensive, and you cannot and don't really want to log everything. It's not scalable. You want to log more, but you want to log in a scalable way. And not only it's not scalable, it can impose security risk, because the more you do logging, the more the chances that you are logging sensitive information. So logging itself can cause problems in reliability and insecurity in the systems. If you are logging too much and the system cannot keep the pace of the logs, then you can either choose to lose logs or make the machine slower or even stop working. The machine could stop working. So we need a balance here in the logs, and the response should be a proper logging for the amount of logging and debuggability that we need. The best would be to start with logging each request and each response, such that we are able to take a request from the logging and run it through our IntelliJ and debug, and put much of the burden of the logging on monitoring and graphs and tables in plain SQL. In 2014, an attacker has put the service of what was called back then code spaces, and does not really exist anymore, out of business. And it took the attacker only a few hours by taking over the administrator tools and deleting all the data from the data center and also all the backups. This emphasizes the amount of time that we have to answer issues. The team must be able to work fast. Developers must be able to find the problem in case of crisis. And this will not happen unless we prepare for it. It's best to have a pre-made plan, best to think beforehand and think less afterhand. When there is such a crisis, we want to operate best as we can. However, we are under stress, so we cannot operate as best as we can. We want to do all the complex work before the problem actually happens, and we want to leave the simple steps for when the crisis happens. So checklists are the best friend. Checklists can help us find the root cause of the problem under such crisis and stress. There is actually a standard for it called ICS, a standard approach for command and control and coordination of the emergency responses. Google has actually an internal tool which is called DIRT, Disaster Recovery Testing Program, which it's regularly simulating, like Chaos Monkey, various internal system failures, and forces the team to cope with these types of scenarios and to actually practice. So it's going to be hard in practice, but easy in battle. Another thing to look at is when you patch, then when you have the error and you reach a conclusion that you need a patch or fixing a code in the system, then you want to ensure that you can do this in a fast lane. And you want to ensure that you have a fast but reliable process for that. This requires, again, preparations. And while it could be the case that your continuous deployment justifiably takes days to get to production, you want to ensure that in these cases you have a fast lane for a rollback or for a patch or for a fix to close all the vulnerabilities quickly. However, to do that, you need to have great visibility into the state of the system so that you know that everything is okay before and after you applied the patch. Otherwise, how could you tell what happened? How could you tell if the patch made some other things worse because it got there by the fast lane? And there are approaches for this the book discusses, mainly with proper visibility into the system. So we wrap up, and I want to say that while security and reliability, they have much in common. They have much commonalities. They still have different requirements which collide. So how do we address these colliding requirements out of security and reliability? The best practice is to have proper visibility and testing, so that when we deploy a fix, when we need to do some action of investigation, that we already practiced it and we are able to provide and to provision the availability of the logs quickly. Reducing the technical debt also helps, because if you have a complex code base, then when the case happens, it does not matter. The code is complex, the models are complex, it's not easy to see into the system. This is a key aspect and a key point in the solution of this mitigation of the discrepancy between security and reliability. And though consumers are not always aware of this feature, they should get aware of it. And once they are aware of it and educated about it, they will appreciate the security and reliability as part of or as a few of the top features, which they do not only think that you should provide on your side, they would think that it's a requirement to have these features of the security and reliability. And with that, we come to a closure where our consumer agrees with us about the reduction of the technical debt and the addition of the security and reliability measures, so that we can all implement it and all be happy with the time that is invested in it. So thank you for listening. I will see you next time.